Welcome Purnandam to this session. Today we are going to discuss about a problem in the simply supported beam with the point 2 diagram. Already we have dealt about the sign conventions as well as CFO's bending moment diagram, nature of diagram curve virtue. Already discussed. So today we have to go for a problem solving methodology for a simply supported beam with the point 2. If you have a simply supported beam having a two different supports at the two extremes. Let's have A and B, and the span of the simply supported beam is 6 meters straight, and a point code is acting exactly at the center point with a magnitude of 20 kilonewton. Okay. And it is acting exactly at the center point. Let's take this is a 3 meter and this is a 3 meter. Okay. Now the thing is to solve this problem to find out the support reactions first. Then shear forces at each and every point. Find the bending moment at each and every point. And with the values we have to draw the shear force and the bending moment diagrams. Okay. And let's have the points A, B, and where the point is acting is taken as C. Okay. Since it is a hinged support, we have a support reaction here. So the support reaction to be taken as or A, as well as point B, the support reaction to be taken as or B. So the first thing is to find out the support reactions. How to find the support reactions can be found by using the statically equilibrium equations. So since we have only vertical loads, I am taking the sigma V is equal to 0. That means the sum of all vertical forces is equal to 0. With the sign convention, I am taking the upward force to be taken as positive and the downward force will be taken as negative. And I have RA is our force, 20 km is another force, and RB is another force. Totally 3 forces. So with the sign convention, RA plus RB and minus 20 is equal to 0. Okay, RA positive, RB is positive, 20 is towards downward axis to be taken as negative. So finally, RA plus RB is equal to 20 kilonewton. So I have one equation. Okay, let's take this as a first equation. Then I can go for another statically equilibrium equation called with respect to bending moment. Okay, so sum of bending moment at any arbitrary point to be taken as 0. So which point I can take? Let's take point A or point C or point any point I can take. Okay, but it is simplified. Wherever the support reaction is there at that point, if you take, it is simplified. So I am taking at point A. So now all the forces will travel to this point A, and the sign convention is clockwise is taken as positive, anti-clockwise is taken as negative. Okay, and you can take anything. Okay, you may take clockwise is taken as positive and anti-clockwise is negative. I am taking, and the universe you can take. No problem here itself. It is according to our convenience. And moreover, this bending moment is nothing but the force into perpendicular distance. Okay. Now, let's take this point. About this point is 20 kilonewton travel to this point clockwise manner, and RB travels to A anti-clockwise manner. Okay. The sign convention is already given. And for this point, RA is the force, it exactly lies on the point A. So RA into the perpendicular distance is here 0 because it travels to point A only, but it lies on point A itself. So there is no perpendicular distance to travel. So I have to concentrate only on this 20 kilonewton and the RB value. Okay. So since it is clockwise, so 20 into the distance, perpendicular distance is 3, and this is anti-clockwise, so it is negative. and that is RB into, so toss to A point, so total it is 6 meter, that is equal to 0. So finally 6 RB, if you simplify, just take it outside the side, 6 RB equal to 60, so RB equal to 10. Okay, 10 kilonewton is the supporting axle at point B. I already have an equation, the sum of RA and RB is equal to 20. Since RB is equal to 10, RA remains 10 kilonewton. So each support carries 10 kilonewton of load. The total it is 20 kilonewton. RA and RB carries 10 kilonewton of Newton. Okay. Now let's move on to the shear force values. So how to find the shear force values? That is very important. Here the time conventions are already discussed in the EMA process. Now time convention. So here it is for shear force. Okay. So right up is positive. Right up is positive. And the remaining thing is negative. You take right up is positive, right down is negative. If you take left up is negative, left down is positive. So by having this sign convention, you can go for anything else. Okay. Before finding the shear force at each and every point, we should have a reference point. The reference point, let's take for B, just nearby this point. For this, just nearby this point. For A, this is the reference point. From the reference point, which side we are going to consider? That is very important. Now, from the reference point, now I am taking the shear force at point B. Let's take shear forces F at point B. What is the value? Okay. So from this point, we consider right side, either right side or left side. Any one side we have to consider, not the whole thing. If you take whole thing, that will be equal to 0. Okay. Consider the right side. If you take right side, you have only one force, and the force is RB. So RB already found out, that is 10 kilonewton. Okay, and it is about force. So right up is from the reference point, right up it is positive value. Okay, according to this, right up is positive. So it is also 20 kilonewton. Sorry, RB equal to 10 kilonewton. And I am going for the point C. What is the shear force at the point C? So now you can go for the right side or left side. Okay. So I will take both things over here. If I take right side, RB and 20 kilonewton. So it is right up, it is right and down. Positive and this is negative. So 10 minus 20, that is equal to minus 10 kilonewton. Okay, in case if I am taking the left side alone, whether we will have the same value, let's check. Okay, or the same value FC at point C. Okay, from this point left side, you will have only one force, RA only. Okay, so RA is left up. So right up is positive, left up is negative. And the value, what is the RA value? Already found, it is 10 kilonewton. So left up is negative. So only one force minus 10 kilonewton according to the sign convention. So both are equal. So you can take either left or right, but the sign convention you have to follow. Okay, that is the thing. So according to this shear force values, now we are going to draw the shear force diagram. Just extend this line and draw the neutral line. That is 0 shear force line. This 0 shear force line, and just mark the values. So force at shear force at B equal to 10. So upward is positive. Let's take 10 kilonewton, and at FC, that is minus 10. So here it comes down, but I am not putting minus because from the 0 it rise in the below. Okay, so it is negative 20 degrees. And what it is FA? Now FA are we not yet found. Okay, just take FA here. Okay, just right answer left. You have only one force, it is RA. It is left up. Left up is negative. So FA is also minus 10 km. Okay, so here FA is also minus 10 km. So according to the nature of curve for shear force diagram, I already showed whenever the point was there is a horizontal line will come. Where the point board is acting, there will be a vertical line will come into the picture. Okay. Now at point B, draw a horizontal line. At point C, you have a value changes from 10 to minus 10. Vertical line. Okay. Next, at point A, it is also minus 10, so both will be same value horizontal. Then just join with the 0 line. This is negative value, this is positive. So this is the shear force diagram for the given problem. Okay. So only a single point what is given for this. The shear force diagram has been drawn. Now let's move on to the bending moment. Okay, just move on to the bending moment. What is the sign convention of bending moment? I already told that. So this is the sign convention for positive sign convention for bending moment diagram. That means either considering the left side, you have a positive means upward force will be there. Right side means upward force must be there. Then only you have a positive bending moment. Okay. So just I'll tell you that positive bending moment will give you the upward force will give you the positive bending moment. Okay. Now let's move on to the point by point. So M, that was the bending moment at point B. Bending moment means force into perpendicular distance. So now let's take from the reference point. We have right side consider either left or right. Now I must right side because only one load, simple. So RB is the load, but there is no perpendicular distance because I am taking the point B. RB into 0. Simply it is RB into 0, that is equal to 0 value. Next move on to the point C. Okay. So M at C point, that is equal to, so consider right side RB into 3 meter. And this load acts exactly in point C, there is no distance. So RB into 3 and minus 20, minus 20 into 0. So what is the value? It is RB equal to 10 into 3, that is equal to 30 kilonewton. The unit is meter, kilonewton meter, that is MC. What is MA? From this point, you consider the right side or left side. Now consider left side because only one force is there, RA, and RA lies on the same point. So RA into, there is no perpendicular distance. Simply it is RA into 0. RA equal to 0. So I am having the MB is equal to 0. M at C point is equal to 30 km. M at A point equal to 0. Okay. Now here itself I will draw. Just extend. So 0 bending moment diagram. Okay. It's a bending moment line. 0 bending moment line. So at B point, MB is equal to 0. At MB, R equal to 0. M at C point, that is 30 km, that is positive value. So from this, like here, 30 km, and at MA, that is equal to 0. Okay? So 0 line. And what is the nature of curve to be drawn for bending moment diagram? When the point load is acting, in between there is no load, so it will be drawn directly joining the line. Okay, from this point to this point, you just draw the linear line. Okay, and from here to here, C to A, these are the point load, so you just draw the line. 30 km the value, so it is a positive bending moment. Right. Okay. So this is the bending moment diagram for the given problem for a simply supported beam with the 20 km point load is acting exactly at the center point. We will discuss another problem in the next class with the simply supported beam with the 2 point loads. Okay. Thank you. Thank you for this session.